get started. Welcome to the Gno.land workshop. The purpose of this workshop will be to inform you a bit about Gno.land, what it is, and the workshop will focus on building an app on Gno.land. And hopefully at the end of it, you'll have some understanding of how the Gno.land blockchain works and why it may be potentially valuable for you to consider it the next time you're writing a Web3 app. To start with, anybody that hasn't already, you can clone the GitHub repository that's on the screen here. And there's some steps in there that you can install your local development environment that's going to enable you to more easily develop a Gno.land application. So, I'm Dylan. I'm a senior engineer at Gno.land. Really into Go. Surprise. And I've been working in Web3 for the past few years. I think it's a really interesting space. And hopefully by the end of this workshop, maybe if you're already convinced, maybe you will be. So this is what we're going to do today. We're going to start with an introduction to what is Gno.land and just give a high-level overview of what is blockchain in general. Gno.land is a blockchain. We'll briefly look at the Gno Virtual Machine architecture, Gno being our variant of Go, almost identical to the Go programming language with some more limited feature set. And ultimately for this workshop, what we're going to do is we're going to develop a Stack Overflow-like application that is running on the blockchain. So now if you missed the link the first time, take a moment, clone the GitHub repository, and go through the steps to set up this local development environment. You'll have a few minutes throughout the presentation before we actually get to any of the hands-on steps. So hopefully that should be enough time. If at the end of that, if you had any issues setting it up, me and Leon in the back here, we'll be coming around and we'll be here to help you out throughout the workshop with any problems you might encounter. So Gno and Gno.land. So as I mentioned, Gno is an interpreted version of Go. It's unique because it's fully deterministic, which is something that's necessary if we have we're executing transactions on the blockchain. All of the nodes need to come to the same agreement, the same result. And it also comes with a persistent data store, which we'll get into a little bit more. Gno has the features of Go up until version 1.17, so no generics. It also excludes anything like network packages or standard library packages that have some features in that are non-deterministic. And Gno.land is the blockchain that runs this Gno virtual machine. So how many people are familiar with Web3, blockchain? Show of hands. Okay, not bad. So just a high-level overview of what a blockchain is. It's not required that you have a, real in-depth knowledge of this to complete the workshop. Essentially, it's a distributed database, immutable transaction history. So you submit a transaction, it's always in that blockchain's history. It'll never go away. It's decentralized, meaning that we have a bunch of nodes that are running ideally in different locations, depending on the level of decentralization. So it's kind of resistant in that way. The state is verifiable, meaning that if somebody submits transactions to the blockchain to perform certain actions, that you can take a look at what those were and verify that the data on-chain matches the execution output of those transactions. And it's trustless, so I can write an app on a blockchain ideally if it's a legitimate blockchain, and I can take certain actions and I can have a fairly high confidence that those actions that I specified actually are what is happening. This diagram just shows you basically kind of a state transition of a blockchain. We have a current state, which is the distributed database, transactions, which are state changes, and they produce a new state. They're referenced by hashes. So block n takes transactions, makes a state transition, produces block n plus 1. And then they retain previous hashes so that it's easy to, it's like a linked list essentially. This is just a, blockchain network, peer-to-peer. Not all nodes seem to be talking with each other at all times, but so the client will submit transactions to a node. The node will propagate those transactions to the network. a block is produced, the other blocks verify. That's kind of where the trust list and the decentralized aspects of the blockchain come into play. So as for GNO specifically, like I said, it's deterministic, lacking some features like generics. There's no concurrency. Basically, it's lacking anything that would make it non-deterministic. It has built-in application state persistence. What does that mean? Well, that means that inside of GNO programs that are written and deployed to the blockchain that are executed, you just need to define a variable, and that variable will be persisted throughout the application's lifetime. No need to do anything else. We support things like importing in the same way that you import in Go, both from packages and you can either import code from other applications that people have deployed, not your own. And all of this, because it's a virtual machine that's running on a node, it's all happening in a safe sandbox environment. Essentially, the interpreter is written in Go, so when it is interpreting GNO code, it's all happening inside of the binary that was built. If you're more interested about compatibility, we do have a link on our docs website, docs.gno.land, and that'll give you the a full view of what's supported and what's not supported. So let's take a look at some example GNO code. So in Go, we call them modules, right? We still call them modules in GNO.land, but the terminology we use is realm. A realm is, I guess you could, equating it to other smart contract platforms, you would call it a smart contract. So let's look at the different parts here. You have your global variables that are defined. And when I talked about automatic persistence earlier, this is kind of what I was referencing. Defining global variables, whenever they're changed in code execution, they will automatically be persisted back to the chain. You don't need to do anything to do that. It just happens automatically. Like in Go, if we have exported functions, these are callable from outside of the module. In this case, outside of the module means I want to invoke a function that exists in a smart contract somewhere, and I know which ones I can invoke because these are the ones that are exported, right? And then, conversely, anything that's unexported is a function that can only be called within the realm itself. So why might you want to use GNO.land? Well, comparing it to other smart contract platforms, the code that you write and that is deployed is transparent. Anybody can look at it. The source code is stored on chain. It's pretty easy to understand, right? Because it's Go. Go is fairly easy to read. It abstracts away any kind of storage concerns, which is nice. It has a kind of something similar to a garbage collector, where things that aren't used anymore, that don't have any references to them, are cleaned up. Another unique thing is that we have a capability that you can define something, we'll get into this too, but you can define something called a render function. And when you define that, you can actually display like the global variables or your state variables in your realm, that if you want to give developers a view into that, it offers good visibility into the application state. And it enables development of these decentralized applications that this is the use case that blockchains are supposed to be used for, so why not make it as easy as possible for people to build and use that? Okay, so has anybody had an issue with setting up the local development environment, or did it go fairly smoothly? Don't be afraid. If you had an issue, one of us will come around and help you out. Okay, no worries. Cool, so let's get started with kind of the building portion of this workshop. So in that repository, there is a folder called P2, and it's under the phases. There's a README in there that goes into more detail of what we want to kind of accomplish in building this Stack Overflow-like application. So the first thing that we want is very basic, is a question, right? That's kind of the basis of what Stack Overflow is. You ask a question, you get an answer. So what we need to do is we need to define a question. We want to write functions that are callable to add questions and also modify questions. So this is kind of the first thing that I'd like you all to take a stab at. Before we get started, is there any questions or ambiguity as to, well, yes?
Is there an extension on Visual Studio Code that can highlight the syntax for me?
Yes, it's linked in the documentation or in the repo. There's this syntax highlighting section. If you follow that link, it'll bring you to the Visual Studio Code extension right there.
Thank you.
No problem. So yeah, the goal for this first phase is just define a question, write some functions that allow you to add and modify questions, and using GNO-dev and GNO-key, you'll be able to test that out. And to give you a little bit more clarity into how you can test this out after you write these functions, how you can call them. Once GNO-dev is started, you might see that it says it starts up a web server, or GNO web. So on your computer localhost 888, and then this is the package path for your application that you're going to build. In the upper right-hand corner, there's a little thing that says help. Now, if you click on that, it'll take you to the screen you see on the right. This makes it easy. It'll have all of the functions that you've defined in your smart contract, or in your realm, rather. And you can type in your key name. In this case, I chose test1. And then you see below, it will actually, the insecure but quick command, if you paste that into your terminal, it'll use GNO key to invoke the function on the kind of the local chain that you have running on your computer. All right, so if you're still working on this, here's something, some more information for you. So when you visit that link, inside of the P2 directory, the render function that you see, that's what is getting called. That's what's displaying what you see in the UI. It returns a string. It's returned in Markdown because our UI will render the Markdown in your browser. You may have seen this concept that we have in there, this kind of tree data structure. It's an AVL tree. We use that in place of maps because in Go, iterating over maps is non-deterministic. So, and this is a key value store. So like, I think the example for the storage for the questions was an integer identifier to a question pointer. And you can, if you have a new question, for example, you can use the set method on the AVL tree. The methods are commented in the code above in the storage file. And also, when it comes to retrieving addresses for when somebody calls a realm and you want to save, who the caller is, you can use this, our standard GNO library. You can do standard.provrealm.address, and this will retrieve this standard address type. That'll tell you, like when you're creating a question, for example, and you have a field in the question that is who asked this question, that's how you can get that information to do that. So when you're creating creation time for a question, you can use time.now like you normally would in Go, but because of the deterministic nature of gno.land, it actually just ends up using the time of the current block.
So always the same time.
Well,
Yeah.
What does that mean exactly, time of your current block?
so a blockchain is a series of blocks that have been produced. So you submit a transaction, all the transactions that get executed in that block, they would all get the same time for time.now. So like you have a block time, this is the time the block's going to be produced, the next one, et cetera. So it's just a static value for the time.
Gotcha.
Yeah, so posting a question, when you interact with a contract, you want to have like an exported function that you've defined inside of the realm. So if you write a new function and you can call it post question or whatever name you'd like, and then when that is called from GNO key, then it will execute the function that you've defined.
What should that function be actually doing? Writing to my GNO?
Yep. So there's a storage.gno folder, and inside of that, or sorry, not folder, file, and inside of that there's a data structure that is a tree. So And there's some methods above there. You just call .set, and that's where you can store the questions that are being created. So I think this is, I know that, onboarding to GNO.land, the concepts are a bit different than maybe what a lot of people are used to. So I'm going to push some code, and hopefully we can use that as a kind of like a reference as to clarify exactly what it is that is being asked and how these applications are built. All right, so if you pull down the latest changes on the repository, I put the kind of a solution to what is being asked, and it's going to be inside of the P3 directory. And then I'll go through that in a second here. All right, so an example of how this might look. Question, struct, very similar to how you would do something like this in Go, right? We have an ID, title for the question, text for the question. The GNO.land specific thing here is this scd.address. This is the type that is the address type that we use. It has a string method on it. You can convert it to a string. And then we have time, created at, updated at. Now for posting, what do you need when you post a new question? Well, in this case, we're just accepting title, text. We have this, ignore the ID for now. We defined the question with the title and the text. What I showed you earlier, the author, this is our method of getting the address that is called the function. In this case, who's posting the question. When was it created? When was it updated? In this case, it's creation, so we'll make them the same value. And then ultimately, we want to store the question on the chain. What happens when we store on the chain? We have this tree type. It's kind of like a map. UN64 to question pointer. It's already defined, so above it, these are the method definitions on that tree, how you can modify it, or a subset of them that we care about. So yeah, you can call set the key, which in this case we can set equal to the size, right? Because if there's nothing in the tree already, it's 0. So it'll be the first one. Next one will be 1, 2, etc. And then we just use generic value interface. In this case, that will be a pointer to a question. Yeah, it's the so you know how when you use GNO key and you make a call, I think when you were setting it up, you defined a key yourself. So that every key has an address associated with it. So it'll be that address.
Oh, address of the key.
I'm sorry?
Address of the key, you mean?
Yes, yeah. It's like a public address associated with that private key pair, private-public key pair. And finally, we do have render. And render is, like I said, this is what gets invoked when you load up the UI. In this case, we'll use a string builder to write this generic, title string, and then if there's nothing there, our question storage is size 0, no questions. This is just iteration. This is already in there, the boilerplate. You don't need to worry about that too much. But if we do have questions, we can get the questions here. So in this case, the value will be the question as we're iterating. And because it is an interface, we will need to do a type assertion there. And then we can print it out, write it to the string builder, and ultimately at the end, we can return the string, and that is what gets rendered. So to see what that would look like, whoops. See what that would look like. I can start it up. Okay. Let's take a look. Let's, all right, no questions, right? Now remember what we talked about. I can go to help. I can use test one. I can type in, what is GNO? Asking for a friend. So that'll produce the string that we need. Now if we go back to the command line, I can actually just paste. I have GNO key installed already, so I can just paste that in there, and that will make the call to the chain. So when we do that, actually what it's calling is this post question function, right? And that ultimately creates a question, adds it to our storage variable that we set up, the global variable, and it just returns a question ID. So let's go back to GNO, our UI. That's GNO dev is running. Refresh. And now it gets rendered because we have that data in our realm storage now. This is kind of the very basic idea of creating a realm, changing some storage, loading it up, and kind of looking at the results of that. Does anybody have any questions about that? Yeah. Right. So there are other features we'll be adding to this application that are more suited for a blockchain. Like, but for this, for example, if you are building an application on gno.land and you build something like this, you can know that when you're looking at the code and you're posting a question, and if you are the only person as the asker that has, say, modification privileges on the question, you can be guaranteed that nobody can take your question down, nobody can alter your question, because the code it's a contract essentially. It's the law in terms of how the data can be manipulated versus, current Web 2 platforms. If you ask a question and somebody doesn't like it, right, they can just remove it. But that's not the case. That's not the case in this particular application. So we're developing it, and when we launch mainnet later this year, it'll be a group of validators that are not under the control of our company. Yeah, so actually in the virtual machine that's running, that is interpreting and executing the code. After the execution phase has been completed, the node has disk storage that it writes all of the changes that have been made. So like a realm, if you define the global variables, these are your stateful variables. So after execution, it tracks all throughout execution what variables have been modified. And at the end, if any of these stateful variables have been modified, then it goes ahead and it updates that on disk so that it's persisted for the next time that the realm is executed. Yeah. Yes?
So is each like P1, P2 its own realm, or is this whole phase, this folder realm is like my local install of, one realm?
So the purpose of the P1 through 5 directories that you see, these are 1, to contain the readmes for each of the phases, and 2, I can push the code as like the solution from the previous phase so that if you didn't get it done, it'll be easy to build on the next. But every time you start up GNO dev in this workshop, it launches a new version of the blockchain. So it's not like these realms are being persisted somewhere. It only is ethereal, existing on your computer.
Okay.
But yes, each P1, P2, P3 is a different realm and has its own
And
storage
once
space.
I cut off that GNO dev, like canceling the terminal, it's gone, the state.
Yes. Yeah.
So one question. So at the moment, there's one node that we have with the key pair that's talking to some main node that's making sure that
So you have the key pair that's stored locally on your computer, local storage. And when you start GNOdev, it starts a node in memory. So when you use GNO key and you sign transactions to send to the chain, it's just sending that to the local node that's running on your computer.
Okay, so the consensus is reached because there's just one node at the moment.
Because there's just one node, yeah.
Gotcha.
So if it doesn't reach consensus, it would not be good. All right. I'm going to move on. So in this, this first example of creating a question in a Stack Overflow-like app. So users can call this function that you create to ask the question. You can modify the render function so that anytime someone loads the UI, you have this view into the state of the realm that exists on the blockchain. The persistent, when you create a question and you set it, assign it to the tree, that tree data gets persisted automatically at the end of execution. It happens automatically, and also modifications, same thing, gets persisted automatically after it's been modified. And in a full-scale network, what would happen after this transaction is executed is that all of the other nodes would be executing the same transaction. So not only were those data changes just changed on the node that you sent the transaction to, but it's replicated and redundantly stored on all the nodes in the network as, the more places that the data is, if something goes wrong, the higher the chance that that data will be preserved. Let's talk about programming using GNO a little more. In Go, like panic is like the worst thing that can happen, right? You only panic when something happens that you just can't recover from. So generally, we tell people not, programming in Go, don't write functions that panic. But when using gno.land, we actually do want to panic. And why is that? Well, if something happens that is unexpected or you can't recover from, using panic will revert all state changes that have been made to the application. And then it will just, that transaction, what it was supposed to do, it won't. And this is a way for us to quickly bail and continue on with execution of the other transactions.
So it's almost like a commit, roll back type of
Yeah, exactly. But right, so any changes that have been thus far, they get rolled back automatically. Let's talk a bit more about determinism. It's necessary due to the nature of blockchains. Like I alluded to earlier, we have to be able to reach consensus, and a good way to do that is to make sure that all our operations are deterministic. We don't support certain network packages or other packages that have non-deterministic qualities. And yes, I touched on this briefly earlier, but time.now, it just returns the time of the current block, not necessarily the true time of what it is right now. And it will return the same time for all of the transactions that are happening inside of that block.
Sorry, question, what do you mean by the time of current block?
Time of current block. In a blockchain, because it's a series of blocks that is being produced, each block that is produced has a timestamp. So it would be the block's timestamp. Yep. All right, so let's try moving on to phase 3. If you didn't complete the last one, you can just start with the code that was pushed into the P3 directory. And this is very similar to P2. So it's just, instead of creating a question this time, you are creating an answer. And the answers should be rendered underneath of the questions. And how you store the answers is up to you. It can be in a separate, completely separate AVL tree, or you could store them within the question itself. And just make sure no matter how you choose to store them, answers do need to be associated with the question that they are answering. So why don't you take a few minutes and give that a shot, and same as before, raise your hand if you have a question or if you're having trouble trying to figure something out. I'll go ahead and push kind of what I'll push one solution. That, you know, it might not be the same as your solution, but if your solution works, it's not necessarily wrong. I mean, it's not wrong if it's working. All right, so you should see a solution to this now. If you pull down the latest changes, it'll be in the P4 folder. Okay, so let's take a look at what this might look like. Let me remove the terminal maybe. Okay, so we have the struct that is an answer. It also has an ID, the ID of the question it refers to, and the answer text. This looks very similar to how we define a question model. Have the author created at, updated at. And also, as you know, you might expect, posting an answer also works very similarly. The exception here would be that, you know, we want to get the question using the ID that was provided for the association. I defined a get question function that is defined in, is it down here? That will try to get the question from the ID using the ID provided, and if it doesn't exist, it will just panic. Because, you know, we can't associate an answer with a question that doesn't exist. Update answer, very similar. First, we want to make sure we have text. Get the caller, get the question. In this case, we need to get the answer from the question before we modify it. And, you know, because these are pointer variables that are being stored, once we get the pointer to something, we don't need to rewrite it. We can just modify the field. And at the end of the transaction execution, when the data is finalized, it'll take care of that persistence for us. And for the solution I came up with, I just stored the answers as part of the question. It seemed an alternate solution would be to make another structure, another AVL tree like we use for the question, and store answers completely separately. And, you know, then we still have the association because each answer would contain the ID to the question it was meant to answer. And we'll take a brief look at render, what that's doing. So it's doing all the same stuff that it was before, except now we're after we write the question data. Now we'll also write the answers as well. So we can just iterate over the answers if they're stored as a part of the question. And yeah, pretty self-explanatory. So let's move on. So what have we accomplished? Questions can now be answered. Answers can also be modified. Again, it's all stored on the gno.land blockchain, questions and answers. And at this, I mean, now we have, you know, a Stack Overflow that has questions that you can answer is a little bit more useful. So here's just a diagram, you know, how this works. You have the client. In this case, the client, what we're talking about is GNO key that you're running locally. So you're constructing this request, and that gets sent over, routed through gno.land, and ultimately gets executed on the GNO VM. And the GNO VM is kind of the core of gno.land in that it's the interpreter. It interprets this Go code, builds up a syntax tree for execution, and execute it, write the state back to storage so that you don't need to concern yourself with that. And when you create a realm, so this is kind of happening in the background when you start up GNO Dev, but in the generally, when you want to create a realm, you have to make a separate request to a blockchain node to create the realm. And what you would do is you're sending over the code that you've written. And the first thing that it will do is it will kind of process that code. It'll build up this syntax tree, and it'll identify these declared types. Well, we need to save those in our data store because those are going to be used for subsequent executions. We need to look at the state variables that we define because, well, we also need to save those as well because they can be changed, modified in subsequent executions. And then we'll run our init functions. You can define init functions in GNO the same way that you can in Go. They'll be run only at package creation and not any time after that. So at the end of this, anything that's left, such as code that's defining variables, init functions, that all gets done inside of the virtual machine, and we write that to the store as well, so that next time somebody wants to use the realm that we've created, we already have all of the base state constructed. It's ready to be called, ready to be used. So what you're doing now as part of this workshop is you're not really creating it. It's already created when you call GNO Dev. You're using GNO key, right? The actual command is GNO key make transaction call. So what is that doing? So it sends a call to the node, and then it enters into kind of our VM module that we've defined. And it'll say, okay, what am I executing? It looks up the package path that was defined in the call. It loads it from storage. After it's loaded it from storage, it says, okay, let's take a look at the application code, parse it, rebuild the syntax tree, and get it ready for execution. So it'll send it to the VM. The VM will execute it. Any side effects that have occurred, like modifying realm variables, these are the persistent variables that are stored on chain. It'll write those to the database, and optionally, if the function that you call produced any values that you want to return, it'll return those values back to the user that called the function. Do I have any questions about, any high-level questions about what I just described? Yeah.
Is the VM running on our local machine right now?
Yeah, as part of GNO Dev.
Okay, and are the values getting therefore stored and such on our local machine, or is that happening on the deployed blockchain on gno.land?
No, this is everything that you're doing is happening locally. Yes.
Gotcha.
Yep, it's just a development environment, so ideally, if it works in your development environment, it makes it much faster when you want to actually deploy to the chain. You've already ironed out all the errors and everything. Anybody else?
So realm creation is when you bring up the GNO Dev?
Yes, that's in the development environment. That's when realm creation happens. If you were doing this outside of the GNO Dev environment, you would actually have to do a different kind of call to send your package to the chain, and then it would be created. And after you've created it, then you can make calls to the chain.
So when it goes out to the chain, then is that when it calls the init function?
Yes, yep. Init function would be called at time of creation, or another way to put that would be the init function gets called shortly before the realm that you've created gets persisted to the blockchain. Okay. All right, so let's try another phase here, phase 4. So now at this point we have questions that can be answered. We're storing both of them. And again, if you didn't quite finish the last one, feel free to move over to the P4 directory and just start from the code there. Otherwise, you just continue to use what you've written. So what do we want to do here? Let's define a kind of moderator. What can a moderator do? They can lock questions and answers. Only the moderator should be allowed to do this. As I just talked about this, inside of init functions, it's only done at time of realm creation. So for example, if you were to, create a moderator and put it and assign it into the init function, you know that's only going to happen one time. And let's also define upvotes. This is an important part of kind of this like Stack Overflow-like community where you're reading through the questions and answers, and you want users to have a sense of, is this quality or is it not? So let's do this. Let's say that questions and answers can both be upvoted, but just start with one, and if you have time, move to the other as well. So maybe start upvoting the answers. Only one upvote per address is allowed. We can do this by, whenever an upvote happens, record the address, and then maybe next time an upvote happens, if we have those recorded, we can check to see if that person has already tried to give an answer to this question or answer. And in the render function, it would be nice if we could have something, change it in such a way so if something is locked, it tells us it's locked. And also display the number of upvotes that a question or an answer has. So yeah, go ahead, get started on that, and we'll be coming around and answering any questions. Any questions just to start off right now? There's also more detailed requirements inside of that P4 README file. Yes?
How do we know which address created the GN overflow package?
Okay, so how when we were getting the address for like who called to create a question? So if you define a variable, global variable, like var variable name equals, and then you set it to like std dot, what was it, prevrealm dot address, addr, that will actually give you the address of who created it.
Okay.
You could define it as a variable, just an assignment, because it's a global variable with an assignment. That assignment only happens once. Mm-hmm. Alternately, you could just define the variable and do it inside an init function.
Okay.
Anybody else? All right, cool. I'm coming around. Yes.
I have a general blockchain question.
Yeah.
So now that I'm creating these smart contracts and deploying them, let's say to blockchain, different folks are going to write different types of contracts.
Mm-hmm.
Are all of them part of the same blockchain or different chains?
That's a good question. So to begin with, because we haven't actually launched mainnet yet, we will launch GNO.land, and everything will be part of the same blockchain. But you can imagine a situation where people uploading data. Not all the data can be stored in the same blockchain, right? So once we have a blockchain that is proven, that is working, actually anybody could spin up their own blockchain for certain use cases, right? And you may. Oh, okay, thanks. Yeah, so the idea is that in the future people can split up, they can even write their own blockchain that even works a little bit differently and potentially just... no, I mean they could write a blockchain completely different from GopherConUS, and they could just embed our virtual machine inside of their blockchain, because there's this ecosystem called the Cosmos ecosystem.
Okay.
And what they have is you basically writing different modules. It's kind of like a plug and play blockchain. Mm-hmm. So you can bring in the modules that you want in your blockchain and just leave out the ones you don't. So you could write your own blockchain, and if we make the VM available as a module.
Provided there's that interoperability or compatibility between those things. For example, if I have this model from gno.land and I'm creating an entirely different blockchain, does it need to be compatible in any way, or is it just
only
because it's VM? So
yeah,
it should just work.
It should. I mean, if you do it correctly, importing the VM should work. I mean, obviously we haven't launched mainnet yet, so there's going to be some rough edges, but that is the ultimate long-term vision, right?
How does this compare to something like Ethereum blockchain that exists, has been for some time?
Mm-hmm. So, the differences.
Pros and cons, or why know that?
Yeah. So, have you ever tried to read smart contracts on Ethereum? So one thing is with Ethereum, when you upload a smart contract. It actually doesn't store the source code of the contract on chain. It compiles it first, and it stores it as bytecode. So you have to use what's it called? Decompiler. I was going to say reverse compiler, but yeah, decompilers to get back to the original code. And even then, it's not always exactly perfect. So one, this is more transparent into what the code is doing. There's functions actually that you can see, actually, do you have it running right now? Yeah. So you can go to source right there, and then you can see all the files, and you can see all this. Anybody can do this, like when a chain is running, right? So you know exactly what you're getting. Ethereum does not have this. And the second thing is just the general ease of development and readability of the code. We use Go, which is like a pretty simple language. Ethereum uses Solidity. It's a bit more hard. For me personally, it's hard to read, hard to understand. So we just hope that if people are interested in doing this kind of development, they can use Go to write applications that can have more fully expressed like data structures and things like that we're used to using Go, but in a blockchain setting.
Cost-wise, how much? I mean, is that also a factor that would play into how people choose which blockchain to?
Sure. Well, Ethereum is very expensive. I mean, we haven't launched mainnet yet, so we're doing work right now to nail down our kind of like gas costs and gas calculation. But I don't know that we'll have really have true knowledge of how expensive this kind of VM execution cycles are until we gather more data. We're actually launching test 4 this week or next week, which is a public test net that anybody will be able to interact with, and we'll have a faucet. So if you're interested, you'll be able to go to the faucet, publish your apps on chain, and mess around with it.
Okay. And do you already have clients who are planning to use this, or what's the?
Yeah, we have a developer program kind of that we've given grants out to people who've expressed interest in building applications on GNO.land. I know one team is working on.
When you say applications contracts or?
Sorry, I mean like formal we would like to a grant to work on this. So somebody's working on a DEX that's going to work on GNO.
Which one?
Like a decentralized exchange.
Okay.
We have people that are building. Someone's trying to build like a kind of like a mobile app for like a Twitter type of like clone, like social application. Somebody was working on like game applications that they want to store like kind of NFT type of compatible things on GNO.land. So there's a wide variety of use cases that people have. I think the selling point is it's just kind of easy to be able to write Go code and just get it out there, write it very quickly, right? An application like this doesn't take as much, doesn't require as much auditing as something like Solidity applications in Ethereum, where they're very prone to lots of hard to identify bugs. Yeah, it's a lot. I mean, if you know how to read Go code, it should be easier to spot the bugs, right? Oh, yeah, no worries.
Okay, thanks.
All right, just checking in here. Some more information. So this is kind of the answer I gave earlier about how to set a moderator when the package is created. This is an example. How should upvotes be stored? Well, if we only allow one upvote per address, it's like a map, right? If the entry exists in the map, we don't want to allow them to upvote it again. So actually, this AVL tree we've been using for using the key or the int as a key. We have another one. Sorry, I should have mentioned this earlier, but this is what it's called. You can use that as the import path. The methods on it are the same, but the difference is that this takes a string, right, as the key. So that means if you have an address and address has a method on it called string. Okay, so you can use that as the key and then just store whatever you want as the value, and that'll help you. That can help to tell you if somebody has upvoted a question or an answer previously and prevent them from doing it again. Don't forget to add that. If you use that, don't forget to add it to the GNO mod file. That's where we store the imports of what your realm is using. And yeah, look, I already said that. You can use the string method on the address to get string representation. What have we done? So moderator is a permissioned role, right? Only the moderator can lock the questions. Only the moderator can transfer ownership of moderation privileges. It's cool in a Web3, as part of a Web3 app, right? Because you can be sure that this is going to be the case versus typical, like a Web2 app, moderators can be added, removed. You don't have any insight into what that process is like or what's actually happening. Now imagine how, we could take this further. We could define different levels of moderation, implement a voting mechanism. It could be all these different tiers that could be built into the application and kind of to reach some kind of a consensus between the groups of moderators themselves. And again, all of this, all the moderation roles that were added, the upvotes that were added, it still all lives in the application, all in the blockchain. Well, that's kind of cool. So this is our virtual machine. I've kind of divided it down into a few separate parts. This is what is executing the code that you write and is persisting the values that you're adding or modifying. Those 3 steps, I've broken it down into like pre-processing, which is parsing, building the tree that ends up getting executed. Execution, that's the interpretation. During this step, it'll start to save references as execution steps are done, save references to what has been modified before finally we get into a last step where we say, okay, these are all the values that have been modified. Now we need to persist this for future executions, and we'll take care of that there. All put into a key value store on the disk. So we have one more phase that we're going to go through. I'll present it. Feel free to try it out. I'll stay here as long as whoever wants me to help them through it. But in order to prepare for that, I'm going to introduce a new concept, and this is the GNOT. This is GNO's native token. Use it to pay gas fees when you make transaction calls. You can transfer it between addresses. You can even send it to realms, and realms, we've instituted some mechanism where realms can transfer this as well. Think of this as, in classic like Web3 terms, this would be what your coin or your crypto, I guess you could call it. But we do that, enable these kind of transfers by using this banker. Banker is an interface where we can take various actions with coins. Coins are both an amount, or they're a denomination that you specify. So coin A would be different than coin of type B. In this case, the type would be GNOT. That's all you need to know for that for right now. You should, and by the way, if somebody didn't hear me earlier, I did push a link to the slides and repo's main README. It's at the bottom, so you can go back and take a closer look at that. So last phase. So it would be cool if we have these tokens and people are answering and asking questions. Why not incentivize it a bit? I have a question I may have asked and nobody responded. It's a hard one to come up with the answer to. You have to do a little bit of work. I can set a bounty on it, and I can say, I'm going to ask this question, and if somebody answers it and gets marked as resolved, it'll automatically pay that bounty out to the person that answered the question. Kind of make it worth their time. So how can we do this? Well, when we call post question, makeTX call has a flag called send, and as an argument to send, you can put in an amount, and then your coin type in this case would be UGNOT. It's like a micro GNOT. You can say this is how much. So the idea is we can write an application. So when you call post questions will now do something else. It will parse this argument. And it will say, oh, somebody sent a bounty. Let me record the bounty in the question. And maybe when someone resolves this, then I can use the banker and I can send it out to the person that resolved it. So let's say, and we'll get in, I'll show you how to, obviously some details of how this can be done. But let's say that moderators and question authors can resolve questions. After something is resolved, no more answers, no more edits, done. If the question has a bounty, pay out the bounty to whichever answer was chosen as the one that resolves the question. Optionally, now this is, don't worry too much about the last bit. I put it in here if you're interested, but we could declutter our question rendering. You get a lot of questions. You don't want to render them all at the same time, right? So we could declutter it by actually just loading the titles. And if you click on the title, it would open up a new page with the rest of the question content. This is taking advantage of the render function's argument, that is a string. You can use it as a path and use that path to kind of navigate through your rendering logic and return the question that you'd like to render. And we can get into a bit more details about that. I'll just put this up right away because this is like the hardest, last one, the hardest one, I would say. And actually, I didn't push the solution to the last one yet, so let me do that. Let me do that now. But take a look through the README that's in the P5 directory, and it does have some links in there to the resources that will help you figure out how to manage like receiving. How to manage sending coins from within a realm. And I will be with you in one moment. If anyone has any questions in the meantime, feel free to raise a hand. So I'll go through the summary first. And like I said, anybody who wants to stay and work on this, I'm happy to stay here and help out with it. But this application, right? We can call it Gno Overflow. It's a nice name. This is like a decentralized minimal feature implementation of what a Stack Overflow application might be. All of these things that we've added, questions, answers, upvotes, mod, etc. Bounties, that's kind of cool. Bounties is something that is very transparent on a platform like gno.land, not quite as transparent. Payments aren't always as transparent when they're built into applications that you're using. By reading the code, you can easily see that if I do A, then B will happen. The entire application, all of its data, all stored on the blockchain for you. You can continue to interact with them. You can be confident that application and its data will continue to exist within the bounds as is defined in the code itself. And anybody can inspect it. I don't know if you probably have seen it in the UI, but when you're in the UI, up next to the help button, there's a little source link. Or whenever you come across a realm that somebody has deployed, you can click on it and anybody can just review the source code. It's very transparent. Bounty payments, we covered that. And we don't need to worry about the author changing how the application works because once it's deployed, it's immutable. That code can't change. That's what it is. If you want to change the functionality, you need to deploy a new application. And we also don't have to worry about data persistence or data being lost because even if you do invoke some kind of function call or action that removes data from a tree or from a slice, due to how the blockchain works, you can always look back at previous transactions and reconstruct an earlier state to figure out what was going on. So here we have we got some links here. Our official website, docs. Playground is cool. It's a UI that allows you to execute GNO code in the browser and make calls to different realms from within the browser as well. I believe you can even point it to your local running chain, right? Local host. GNO in play. Yeah.
Yeah.
Yeah. And follow us on Twitter and check us out on GitHub. We have a lot of people active in adding issues. You see something that's wrong, contributing, and we are also hiring as well. So if you are interested in really contributing, then you could check out our hiring page. I think you can get to it. Can you get to it from the main website? Yeah. Yep. From the main website, you should be able to navigate if you're interested in that. So yeah, if you want to continue to work on the phase 5. In the meantime, I can answer any questions. Yes.
What is gas?
Gas is, you can think of it as like a unit of work. So like when you have different VM executions or you're deploying something, we calculate a certain number of gas that must be paid in order to complete that execution or complete that work. Like it's both execution and like the amount of bytes that will be stored. And then we have a gas price that this much gas and this much gas price. So this is how much it will cost you to execute that transaction on chain. It's a way to make sure that, you know, avoid spam and things like that.
Can you show us like how to build the application? Do you have like this GNO has any like a recommendation on how to deploy and how to host that from an infrastructure perspective?
How to deploy a node?
Yeah.
Yeah.
Or how you like propagate the deployment to multiple nodes?
How you propagate the deployment?
It's not necessarily something for GNO. You know, like you're just asking if there's a recommended path for it.
We like right now we're in the process of setting up a network which is composed of multiple nodes, and for this reason there is now the documentation gno.land. Like there are indications on how you can actually set up multiple, as they're called, validators together, and so you know that's how you would set up a network. There are many sort of details which we are still figuring out. But yeah, that's, you know, there's the documentation there if you're curious to check it out.
Cool. I'll check it out. Thanks.
So the future work is this. So if you make an application right now, it stays in our system and we cannot deploy it on the mainnet or something. Is that correct, right?
You can, if you deploy it to like our testnet that we're launching, it will stay there. You'll be able to deploy it to the mainnet too because they're different chains.
So what's the difference, mainnet and testnet?
So they're two separate blockchains. So like you have your testnet blockchain that's running, that is one. That's why when you do make TX call, you have to specify the chain ID that you're sending it to, right? And so yeah, they're just separate blockchains. One is for purposes of testing, and then when we launch mainnet, this will be for purpose of, you know, mainnet. Well, thanks everybody for coming, and I hope you enjoyed it, and I hope you're able to learn a bit more about gno.land and are inspired to build something on it in the future. Make sure to check out our GitHub. We've got a lot of people contributing, posting issues, making PRs. So yeah, join in, and we look forward to hearing from you.